Welcome, everyone. My name is Brannick. We got Jimmy on here and Aman. We'll go through some quick intros for you guys. And yeah, excited to get kicked off. Appreciate you guys taking time out of your schedules to jump in with us. Hopefully, this is helpful and insightful. I graduated 2019 from BC, from Minnesota originally. I'm actually back home there now. And about halfway through BC, I started a company called Aereo. We built vertical SaaS software for real estate photographers across the country. I was a finance major, computer science minor. Honestly, most of my time was spent just kind of programming and building out the Aereo business in my free time. And honestly, we spent probably about 2 years just trying to figure out how to even get the website up and working consistently and getting the basics going. So for me, I always wish I had kind of like a speed run little course that kind of pointed us in the right direction, showed us the basics of what we needed to learn on the web development side, and kind of give the basics. Really, a lot of stuff that I learned over the first kind of year or two as I got into things. And hopefully, that is what this course is for you guys. And kind of one of my reasons of doing this, I would talk to a lot of BC students that either wanted to start a company or wanted to get into software, but wasn't sure where to start. They took the CS courses, but they wanted to be able to build something a little bit more tangible outside of the coursework. So those are all the things for me. And hopefully this course is able to do that for you guys. I will hand it over to Jimmy here quickly, who can introduce himself, and then I'm on.
Perfect. Hey, everybody. Really excited for this. My name is Jimmy McDermott. Graduated in 2021. Was good friends with Brannick in college and was also building a company during my time at BC and my time before BC. Long story short, spent the last 7 years or so building an ed tech company selling to school districts. And we sold that company about a year and a half ago, and Brannick sold his too. I think he was being modest about that. And so, yeah, same situation where we were trying to figure out, like how to build the thing. And so, yeah, excited to be here and chatting all things web development. Hand it over to Aman.
Yep. So I'm a junior at BC. I'm a computer science and math major. I have a data science minor. And I was talking with Brannick because I know a lot of kids at BC are looking to maybe start their own software-based company and having troubles with the early stage problems. So, I'm just going to be the on-campus wing of this program. So any questions you guys have, you can meet up with me. I'll do my best to help you guys out. But I'm just going to try to, let this go as smoothly as possible. But I'm super excited that Brannick and Jimmy are, leading this. I think it's going to be a great course.
Yeah. And I mean, you guys keep us posted on any questions or feedback. Feel free to send an email to me or any of the other guys. Also, feel free to use the chat here. I'll try to keep my eye on it. So if you guys have questions as we're going, just type your question into the chat and then we'll answer it. And yeah, hopefully it's helpful and productive for y'all. The other item on here is we got some notes that are published. We'll post all the recordings and email those out after each day. So if you miss some or you got school studies, etc., we'll go through that. And then we've got this GitHub repo where we type up all the notes. So on the base page here, we got a little bit of overview. We'll fill this out with each week of things that we're going to go through. And then there's some folders up here too. If you want to click into the folders, you can read all the notes that we're going through and different details. So we'll try to keep this up to date. Some of this is old content, so it might be a couple typos and whatnot, but it should be hopefully a decent resource for you guys. And yeah, with that, let's get started, unless there's any questions off the bat from anyone. Let me open up the chat. Perfect. So this is what we're going to cover today. We're going to go through all these concepts. Honestly, the first probably 2 weeks of this, guys, is going to be a little bit boring. It's just like super basic stuff. You probably know some of this stuff already, but we're just going to go through the basics so you can kind of know how to think about these things. And like, I think that was one of the biggest things that Jimmy and I found, is that there were so many online courses that started with like how to get started with React, or like all these complicated frameworks that do a lot for you, but it's like, okay, how does things actually work at like a fundamental first principles level so that you can then know what you need and what you don't need.
The other thing I'll add in there real quick too is that some of you may have seen or maybe even used already some of the really amazing AI tools that are out there for that make it way easier and way faster to get things off the ground. Those are amazing tools, and like Brannick and I both use them daily, and we're going to teach you guys about them. But we've also found that it's a detriment to jump straight to that without understanding what they're actually doing under the hood and the types of things that they're creating for you, because you get yourself in a situation where all of a sudden the thing has gotten away from you and it maybe works, but maybe doesn't, and you don't really understand what's happening. And so we think it's really important to like understand the fundamentals, and then we're going to progressively and quickly build up to the really cool stuff, including things that can write, full websites for you and all sorts of fun stuff. So, but yeah, that's the core of it for the next few weeks.
Other thing I'll add out, we're going to have speakers come in each week for like 10 minutes or 15 minutes at the end. Usually all CTOs that are former BC alumni that come in and share some of their experience, which should hopefully be interesting to you guys. Maybe they can share some of their tech too and things that they built in the day-to-day, so you can kind of see how things compare. But honestly, the stuff we're going to be going through is stuff that will be applicable in any web development job that you get. So hopefully it's helpful in your guys in the job search. So let's jump right in. We're going to start with routes. Routes are just like URLs. This is what you know when you go to a website, right? If you type in google.com, we're going to break down what's going on when you go to google.com. So these are a few components of a basic URL here. Up first, we have what we call the protocol. And then after that, we've got the URL here. This whole thing kind of encapsulates together. That is the URL. That middle chunk, so if this is google.com, that Google, that's called the second level domain. And then the .com is called TLD, the top level domain. You guys probably know .org, .co, .ai, .io. There's all these different TLDs for different websites. And for websites in general, any unique combination of a second level domain and a TLD is like a unique website. So you go buy something new, you want to start a new company, you buy, the heights.com. Jimmy, I think we own the heights.com actually. But if you buy the heights.com, the heights is going to be your second level domain, and then .com is going to be your TLD. And then every year there's like some governing agency out in the world, and they issue a bunch of new kind of made up TLDs that you can buy, which is why you might see some random ones in the future. And then this first thing here, this is the protocol. We won't go too much into this. If you guys take like computer networks, they'll probably get more into some of that stuff and how it works. This stands for Hypertext Transfer Protocol, and the S is secure. So it's like an encrypted protocol. And you might have seen without the S on some websites, but most websites now are all secure. But we can more or less ignore that and just focus on this. Now, we'll add a couple things. Sometimes you might go to a website and you notice that there's something before the domain. So for example, if we, for a second, head on over to google.com, up in our browser window, we've got google.com. And then the subdomain here, so that's what that's called, a subdomain, is www. Some websites, most websites, end up redirecting you. If I just go to google.com, you'll see that it adds the www there. That's just redirecting me back to kind of the same root domain. Now we could go to like mail.google.com. That's going to send me over to Gmail. I probably don't want my email up there, but that'll send you over there. If you want to go to like news.google.com, that'll send you over to the Google News page. That's just another subdomain on this. And if you buy a domain, so let's say you go buy theheights.com, you own theheights.com, you can have an unlimited number of subdomains underneath it. You can make up a bajillion things. You can type in any word you want down here, and it'll be its own kind of subdomain. You can think of this as just like a big folder on the website that exists. So that's your subdomain, your root domain, or your second level domain, and your TLD. And then also add any questions if I'm going too fast or it doesn't make sense. These are hopefully just some good terms to know, though, as we start to build websites. This is a more complicated URL, but this probably looks more like what you typically see out there. So we've got the protocol first. We can kind of skip that. They call this whole thing in the middle the host. So that would be like news.google.com. The port, we're going to skip over for now. But then there's this /. So, you go to a lot of websites and it says like /, maybe you go to bc.edu / like classes or schedule or something. And that's usually pages. They usually represent different pages on a website. And then we have something called query strings, which I'll touch on the next slide here, a little bit more detail. But like if we go to google.com again, let's see here, google.com. And like, let's go to, or let's try typing in a search. So let's type in Boston College. You'll see up here, our URL changed. We're still on google.com as our primary domain. We've got the subdomain of www, and the TLD of .com. And we're /search. So we're now on the route search. That's what they call that. That's the route. Anything after / is a route. And you could have a bunch of things after this. So let's say /search, slash news slash URLs. I don't know if this is a real URL, but this whole thing afterwards here, search slash news slash URLs, that's the route. And that's super important just to understand like how these URLs are structured, because we're going to start building websites. You guys will be able to design URLs for people to go to your website. Maybe you have a login URL. I bet there's a / login or a log out or a register or like a pricing page on a website. Those are all different routes and typically different pages for people to access. After that, there is sometimes what we call a query string. And I'll give it a second. Let me just check. I don't think there's any questions so far.
I'm watching for it too.
Okay, cool. So after this, there is a query string. And a query string is this optional chunk of code, basically, in your URL that passes the page data. It's like a bunch of variables that get sent to that page. So each page on your website, this is the route or the path is what they call it here. Let's break down the query string a little bit more. This is how we can tell the website we're going to, like, hey, we want to send you data on this page. So for example, if we type this in from scratch, google.com/search ? Which means that we're going to start sending a query string. I'll go over it in a little bit more depth here in a second. And then Q, which is our search parameter, I can type in Boston College. And look at that. It's going to send me to google.com and it's going to send in Boston College. We can type in Jimmy's name or just Jimmy. We got Jimmy Jones there. And that loaded in on the page here, that search parameter. Even if I change that, you can see up here, it actually changed the URL. And you notice there's a bunch of annoying text afterwards. We can delete most of that. Let's see here. You can see that's a nice clean URL. And hey, there's Jimmy. /search. So let's break down what's going on here in this URL. We've got the subdomain, the www. We've got the domain, which is our root domain, then the .com, so the TLD. We're on the page. So for Google, that's search, /search. And then there's one question mark. And the question mark tells the computer, hey, we're going to start passing a query string. And I kind of think of it as question. I got a query. I'm going to be sending a bunch of data after this on over here. From there, it's a bunch of key value pairs, just like you guys have in computer science class, where you've got like a key and a value. So it's just like a simple tuple. The key is going to be some variable name. It could be anything. And then we've got an equal sign, and then that's the value for it. So in Google's case here, their standard search design says, okay, anyone that goes to google.com/search and then starts a query string and passes us a Q, the Q stands for question. So you're asking Google a question. And then the value we want to ask Google is Jimmy McDermott. And you can add a space here. Your browser will figure it out for you. And then that passes it in to that page.
Hey,
Does
Brad.
that make sense?
You
Yeah.
got a really good question in the chat. Why would somebody ever use a subdomain if you've got unlimited paths and subdirectories available to you?
Very good question. It's a little bit up to personal preference. So some websites do it differently, but typically a good way to think about it is if it's like a different kind of application or something. So for example, with Google, typically they do it. So like news is typically its own, like if we go to news.google.com, that's going to be its own like area. If we go to videos.google.com, that'll be its own. Okay, that's not one. So we got an error here. But typically it's like different businesses or different things you're building. A lot of people will have like blog.yourwebsite.com. So like if we go to aereo.com, this is the business I started at BC. And we head on over to our blog here. Check that out. It's switched over to the subdomain blog. This is actually routed to a different server. So we'll get a little bit more into the details of how that works, but it's really easy to route subdomains to different servers. So we've got a different server that just runs, and it just runs the blog. And then if we go over to log in to our website, you'll see that it's on app subdomain. So that's where all of our customers log into, is on the app subdomain. We've got a different server that runs the app, a different one that runs the blog, a different one that runs the website. Jimmy, I don't know if you want to tack anything onto that explanation.
Yeah, I think that's about right. And if you guys start paying attention to when you log into like different applications you use, like app.domain name is like pretty standard and common. You'll notice that like most of the core functionality tends to be hosted like that. Also because, for example, like the marketing site, like what Brannick's looking at here, right? This might be hosted through like Webflow or Weebly or some like builder, right? And you want your actual functionality that you're selling, that is the core software you're developing, to be its own kind of thing. Routes, I usually think of routes more as like paths within kind of a single contained function. So like within the application, you're going to have /login/customers/ whatever. So yeah, that's how I think about it, at least. But to Brandon's point, there is a little bit of like aesthetic design that goes into it. You can kind of pick and choose what you want to do there.
Usually if you have different teams working on different parts of it, like this way, the marketing team can update the site at the same time the engineers are working on the application. If one goes down, it doesn't impact the other, which is kind of nice. And we'll get more into that.
You've also got a good example with your customers, right? Didn't you guys do a separate subdomain for each one of your customers?
Correct. So all of our customers would have their own version of the website. If you wanted to sell to businesses, and each business, like let's say you're selling to sandwich shops, and you want each sandwich shop to have their own individual website, you could do it like that too. So there's a lot of flexibility with that. But as you guys pick around on the internet now, just pay attention to what URLs you're going to and start to see the different parts of it and how it's structured. You'll start to see stuff being pretty similar here. So this is query strings. It starts with a question mark. It passes some variables in, key values, and then you can add as many as you want here in the URL. You just use the ampersand sign separator here for each of those key value pairs. Does that make sense to everyone? And this is a really good link in here if you want to click this SEMrush one. So like 10, 15 years ago, when Google was ramping up, everyone would try to put all these certain keywords into their URLs to get their website to pop up on Google with SEO. So they put in like best shampoo in the world is like the route. So when someone Googles it, pops up. Some of that stuff kind of changed a little bit now, but that's what you may see on a lot of blog articles and stuff. And then the next concept I'll introduce here at a very, very basic level is the client and the server. So what happens when you go to google.com here? So your computer is the client. So my laptop here is the client, and I'm accessing Google's server. Now, server sounds kind of complicated. If you think about when the internet got started, it was started on college campuses, and it was a way for two computers to talk to each other. All Google server is just another computer, typically without a screen. And I think that's the best way to think about it. All the internet is letting two computers talk back and forth to each other. So I said, hey, Google, I'm going to your website. I want to go to your computer. And then they send something back to my computer. So when I make a request for a web page to the server, I made a request to Google. Google replied back with that web page, all that data, and then it's running on my computer. We'll keep touching on this difference between client and server, but a lot of the internet, especially in recent years, has been how can we make that experience as seamless as possible? If you guys go on like a really old website, it seems kind of slow and you're kind of picking around page by page, whereas like a really modern website feels like a mobile app, super like local, very fast, speedy. So we'll touch on some ways that you can make that feel like a seamless experience for people. That was some of the basics around routes and query strings. Does anyone have any questions they want to put in the chat? Otherwise, I'm going to jump over and show an application called Postman. So Postman is a tool. It's just like, you can find the slides. I'll email them out afterwards and we'll link them onto the GitHub page for you guys so you can have access to the slides. But Postman, let me just log out my account. Let's sign out here. We're going to have you guys download this, and we'll send out a list of tools for you guys to download. Look at that. We went to getpostman.com, identity.getpostman. So this handles everyone that logs into this company's website in the /route login. But let's just go back to postman.com. Here's their marketing website. We're going to have you guys download this. It's a free tool. It's basically just like Google Chrome or Safari. It's like a web browser, but it's for developers. And it lets you interact with APIs, which we'll touch on what those are. But you can also just get a normal website. So I'm going to open up Postman here. And for example, I can make a request. We look right here in the middle of my screen. I get a little address bar, just like I do in Google Chrome. And I can type in HTTPS google.com. And that is going to send a request to Google. And we can see down here, it gets loaded. There's a whole lot of other stuff on the screen that will increasingly show you guys on how it works. But this is just like a web browser. It just shows us as programmers a little bit more of what's going on behind the scenes. And you'll notice, let's go ahead and type in and add a query parameter. So if I want to add a query parameter, first I'm going to do the path search, and then I'm going to do the question mark. And then I type in a Q. So that's my variable. Notice as I'm typing here, it's adding the key value pairs down there. So we can search for Jimmy. There we go. So the key is Q. Jimmy, you can actually use their interface then to do it. So if I want to type in another one, then I'll say McDermott, and it'll add it in. So it's kind of nice. It gives you a nice visual interface for what's going on versus having to always type things out by hand. And when you're using APIs, we use this all the time. Most companies use this to hit endpoints. And we'll go on to these different tabs and show you guys what all this stuff does. But if I go ahead and send that request, sometimes they may block you depending on what the website is. But you can see the data that gets returned back here, which will teach you guys a little bit about HTML and how all this works. It looks really scary. It's not. It's quite simple and quite basic. But with that, I will hand things over to Jimmy to go through different HTTP verbs.
Perfect. Here, I'll take over, Brannick, so that I can share some of the other stuff we're going to show. All right, perfect. So one of the like really fundamental concepts that you're going to hear us talk about repeatedly is that everything is text. The whole internet is only text, and that feels a little weird because you see images, you see videos, you see interactive stuff, you see things that change when you click certain buttons. But at the end of the day, everything, the website itself, the data that's coming through is text. The way that text is formatted is different. And one of the ways that text gets formatted differently is through what we call HTTP verbs. So what you've seen in all of the requests that Brannick has made so far, and in what happens when you go to your browser every time, without this, there's no exception to this. When you navigate in your browser through the menu bar, you're making a GET request. You're saying to the internet, get me the content that I just asked for, right? So I don't know if there's I'm sure there's stats on this somewhere, but the vast majority of the internet are GET requests, right? You are asking for a resource to be returned. But what happens when you want to save something to a website, or you want to delete something from a website, or you want to log in, you want to send data back to the server, to that computer that Brannick mentioned that's just like sitting in somebody's closet, sitting in Amazon's, data warehouse, right? What happens? We need some way to tell the internet, hey, we're not actually asking for something right now. We are telling you and telling the server that we want to send something back. Does that make sense? So there's like two modalities there. We can get something, we can give something back. Does that track? Any questions on that? That's like a super core critical concept. And Brannick, feel free to add anything if I missed anything there.
Yeah, another way to put it, when we go to google.com, we're making a GET request to Google server. We're saying, hey, we want to get data from you guys. Send your data our way. So you can kind of put it into logical terms that way.
Yeah. Anything you do, it is not possible to make anything other than a GET request from your menu bar in your browser. You can make post requests, delete requests, and put requests through Postman and through some other services. But if you are just browsing the internet, everything you do by navigating to a website is a GET request. So let's take a look at what this actually looks like in practice. And before I go to this site, let's talk a little bit about requests. So when you go and make a GET request, I mentioned that everything is text, right? And if we go back to Postman, and I'll do the same thing that Brannick did here. Oops. There we go. Okay, so here is the website that comes back from Google, right? If we look at, sorry, I got too many things open. Okay, this is the wrong thing to show. So hold on, we'll come back to that. So when you make that request, what's actually going over the wire to Google is something that looks like this. It's formulating this piece of text that says GET in all caps space HTTPS google.com, right? HTTP v 1.1, that's the protocol version, and then some other data related to the request itself. This is all metadata that tells Google's server how to react to something. So for example, this user agent is telling Google that, hey, the client that Brannick or me made the request through was a web browser, or it was Postman, or it was a phone, right? It was some device that enables companies, for example, to listen to that metadata and build analytics around how are people visiting their websites, right? So that's the data that your client, remember Brannick talked about client and server, so your client is sending to Google and saying, hey, give this back to me. If you're bored and you are super interested in this, this is all controlled by a specifications organization. You can go look up the HTTP spec. It's like a literal 100-page document that details exactly how this piece of text has to be formulated. The good news is, 30, 40 years into the internet, whatever we are, all of this is abstracted away, right? So it's good to understand what's happening under the hood. But as programmers, I have certainly never done this. I don't know if Brannick has. I have never by hand crafted this statement, right? This gets crafted for you by all the tools that are now available in programming languages and through Postman, et cetera. Does that track? Anybody got any questions on that before we talk about Post?
This is what happens when you hit enter on your computer browser. Your
Yeah.
browser forms this and then sends it off to a server for you. It's not super important to know all the details on this, but it's just the general concept.
Perfect. All right, so let's talk then about about responses. So you say something to a client or to a server, right? You say to Google, hey, give me this data back. And then your client's expecting something. Your web browser is expecting something, Postman's expecting something, your mobile app's expecting something. It's waiting for that server to say, hey, here is the data that you just asked for. Now, that data can be in a lot of different types of formats. The format that you're seeing here is a format called JSON, which we're going to talk much more about. But that is one way in which a server can communicate with a client and provide data in a structured way so that you can access it in a way that you know the format ahead of time. The data that we're seeing from something like Google, if we look at the raw HTML here, again, just text. It's complicated text, and it's got all sorts of weirdness in here that we'll talk about, but it's just text at the end of the day. And so the client has to be responsible for understanding what to do with that response. In this case, we know that we've asked for a website. And so my client, in this case, Postman or your browser, knows how to render HTML, right? It knows that it has received an HTML string back, and it knows what it's supposed to do with that string when it gets it. Just like if Google had sent me back JSON that looked like this, presumably the client that's asking for that data, it knows what to do with it once it gets it, right? So it's this request and response model where you say, I want something, server says, here you go. You say, I have data back for you. Server says, great, thanks. Here's a response acknowledging that, right? Back and forth, sometimes hundreds or thousands of times per page that you visit. And we're going to talk more about the developer console, which lets you see that. But this is very rarely only happening once when you visit a website. This is happening tens, hundreds, thousands of times behind the scenes to render different parts of the page, to bring in analytics, to send analytics back, right? To do all sorts of purposes. So these are constantly firing behind the scenes when you're doing something in the internet. All right, let's go back, and we're going to use this really cool site called Request Catcher. And all this does, and any of you can try this as well. It's just, is it requestcatcher.com? Yeah, requestcatcher.com.
Yep, that's it.
And what you can do is it gives you just a basic URL. If we go back to our earlier concept here, this is the one that I've started, which is jimmy.requestcatcher.com. So this is the subdomain, right? I chose Jimmy. I would assume the way this is built is none of you could choose Jimmy because I've chosen it, but you can't have multiple subdomains with the same name, right? It's unique. So this is mine now, and it's got this / of test. So what you can do with this site is if I send data to this unique URL, we can see it come through on this site, and we can actually inspect what that request looks like. So let's use Postman to try that out and see what this looks like. So I'm going to go into Postman and make a GET request to start. Now, what I'm expecting to get back, well, actually, I don't really know what I'm expecting to get back, but presumably there's some HTML that's going to get sent back when I hit return, right? So let's see what that looks like. All right, so what it actually returned was not HTML. It just returned raw text. And that text just says request caught. That doesn't really mean anything, right? But presumably, if you are interacting with a service that you know about, you know what to do with this response, right? There's something that you program around the fact that this now says request caught. But if we go back to Request Catcher, the cool thing about this is it's logging out what it received. So in this case, it's saying something just made a GET request to /test. HTTP requests are stateless, meaning that there's no information that is inherently contained in those requests that you don't manually add to the request, or that a library or a browser adds for you. So this website by default doesn't know who I am, who made this request. All it knows is it received a GET request to /test, and it's going to return what it's supposed to return for that request. We can see here in this case, it is Postman in this case is actually sending additional information like my token, my user agent, right? Metadata that doesn't really matter that much, but you can see what it's sending. Let me pause here before we go to put and post and delete. Does this make sense? Any questions on this? This is, again, this is the introspection to understand what a server is receiving when it gets this request. All right, cool. All right, so let's show a post request. Oh, I see something in the chat. You mentioned stateless. What is that? Is that important? Yeah, good question. It's probably not important for today. We'll probably go more into it, but stateless generally just means that when you send a request, you need to include all of the information that you want to include in that request for the request to know about it. There's no inherent database or storage mechanism happening in that request that will like remember who you are, remember anything like that. So you have to always send all of that information with every request, right? Cookies to log into a website, authentication headers, we'll get into all that. But so there's just no, you have to do the work every single time on the request. That's all I meant by that.
Kind of like when you're in Google Docs, that's a good example of they keep the state updating continuously. You don't need to hit the save button, right? It's always
Exactly.
as you're typing in Google Docs, what behind the scenes, they're sending a million different post requests to the server at Google that's continuously saving your work. Whereas some websites, you might have a big save button. If you forget to hit it, you lose your work, right? Then it all goes away.
Exactly. And the cool thing, and some of what we're starting to see here is that because the client needs to know it's in charge of rendering what it receives, you as the user, as long as you control the client, you can see everything that's happening behind the scenes. And we're going to talk a little bit more about that, but all of this is open. It's not a secret how websites are implemented. You have the tools, and we're going to show you how to use the tools to actually see how websites work, because it has to return all the data to you, right? It has to give you everything and for you to be able to render it in the browser. All right, let's show what a post request looks like. So remember, GET is me asking the server to give me data back. Post is me saying, I am giving you data, right? The server on the other end is expecting me to send it like an email and a password to log in. And that server knows that it's going to get that information. And so it's waiting for it. So in this case, the cool thing is that you can also send data. So you're not just saying, give me data. You're saying, here is the data. There's a number of different ways you can send data. You can see some of those here. We're going to talk more about that as the kind of course goes on. For now, we're just going to use, Brannick, is JSON not a direct option here? I guess you got to go raw.
Yeah, raw and then JSON.
Okay. So we gotta, so we're going to type out some JSON, which again is this format. And I'll explain what this means.
And another format that we just learned about was query strings. That's a common format where you can see it. But what if you don't want the users to see the data that you're sending to the server? Well, you can pass it this way, which is just another way to do it.
Right. Because we don't want the password getting stuck in the URL bar, right? That's insecure. That's bad for everyone. So we're going to send it along with the request. Don't worry too much about the syntax here that you're seeing with the curly braces and the quotes and stuff. We're going to talk more about JSON, but just know you can kind of interpret what this is saying, right? Email : Jimmy, right? My email, password : right? So it's just key value data. All right. So I'm going to go ahead and send this. We get another response back from this server saying request caught. That's all we're getting from it, right? But if we go back and look, we now have a post on the /test route. And if we look at this, if I flip just between these, right, most of it is pretty much the same. There's a few key differences. We're seeing that the verb up here has been changed to post because that's what we sent. There's a few additional pieces of metadata. These are called headers. We'll talk more about that, but the few additional headers added. But then most importantly, we have now also included the data in the body. So just like when I make a GET request to Google, and it's now my job to render that site because I made the request, because this server has now received data from me, it's the server's job to do something with it. to go check and see if that password is valid, to check and see if the email exists, to do whatever is necessary with that request, right? Me as the client, I've done my job. I've sent the data. I'm good to go. And now it's on the server to do something with it. Does that make sense? Difference between get and post there? Brannick, anything to add?
And like, honestly, guys, this is it. Like, all websites in the entire world are literally just pretty much get and post requests, maybe delete too, and a couple others, but you're sending data and you're getting data. I was on a website last week. I won't name the company, small company. It probably had like 10 different pages on the website. It let some people submit their schedules and let other people get, book their schedules. That company's doing like 3 to 5 million a year in revenue. And it is the most simple thing in the world. Like, that is it. There's just like 10 routes. We'll go through the routes. You can post data up, you get data back. And actually, Jimmy, maybe let me share my screen for a second. I have a good demo website I'm going to show. This is an admin panel. It's just kind of fake data. But this probably looks more like a website you guys are used to out there. But here we are. We're on the demo subdomain on the website, filamentphp.com. And we're on the route blog/categories. So that's our path there. That's our route. We basically go to the server. We say, hey, server, give us all of the categories that are available. I'm going to go ahead and open up my Chrome inspection tool. So what I'm going to do is I'm going to right click in Google Chrome here. So if you guys right click, you'll see this option down at the bottom called inspect. And it's going to open up this thing on the side. We're going to use this a bunch. I'd highly recommend getting comfortable with it. Pretty much any job you have, you're going to have this open all the time. And there's a bunch of tabs up top here. Today, we're going to focus on network. Okay, so I'm going to head over to network tab. I'm just going to go ahead. I'm going to reload this page. And you'll see these are all requests. So these are all the things behind the scenes that my browser is requesting from the server. There's a lot of noise in this, but the one I'm going to look at first here is called categories. This is that first request. So I went to the website, /blog/categories. So that's the request URL. We made a GET request. The server replied 200, which we'll cover in a second. And you can check out the response. It sent back a bunch of HTML. It sent back the website. It sent back all of the data. Like, this is how a website works. Now we can go ahead if we want to. I'll move my little Zoom thing. Let's go ahead and make a new category. New category. Description will go in here. We can go ahead and hit create. And let me just filter down so you can see this a little bit easier. I believe this was my create request here. You can see we made a post request. So we said, hey, server, here's the, I think it's a little messy looking at some of the stuff, but we just made a post request to the server and we submitted a new category. The new category is probably on the last page down here somewhere. If we keep scrolling down, we can probably find it. So pretty much all websites are just combinations of getting data, updating data. You can go and you can edit it, and you can see the request to edit it below in the sidebar here. We'll send out a good example website. There's one that's better than this that I'll send out to you guys if you want to pick around and just see how it works. But the same thing goes for delete. Jimmy, I'll let you get back into the other request types there.
No, this is great. Yeah, that's awesome. And I would highly encourage you guys to, like, as you're navigating websites, like, pull this up and just see what requests are going back and forth. Like, you'll see the data. You'll even see data come back from the server that doesn't get displayed in the website, right? And a thing that companies often do is they will send way more data to the browser than what is actually needed to display the site. And you can see that because it's getting sent. One thing that Brannick, I'm going slightly off road here, but one thing that you guys should check out, and I think by the end of this course, all of you will have the skills to do this, is this site. It's called reverseengineerthissite.com. This is a site that I built as a part of my hiring process for my new company, because a lot of what we're doing is using AI to reverse engineer websites, which is what you just saw. Look at the insides of websites, figure out what's happening, listen to the responses coming back and forth. That site I just sent is a challenge where it's a sandbox fully designed for you to go and inspect what's happening under the hood, right? It's encouraged. It's like the point of the site. So if you're interested, sign up and poke around, because it's a really good example where the whole point is to watch it back and forth. And by the end of this course, for sure, you'll have the skills necessary to do it.
When we were at BC and we had to pick new classes, they give you the class pick time. I don't know how they do it now, but there were some classes everyone wanted.
Do you have to use the terminal thing still? Is it gone? Okay. Yeah.
But someone made a website that lets you queue up which classes you want. And all they did behind the scenes is they made a bunch of requests then, as soon as your time slot opened, and then you could request your classes instantly. And you never had to go log in. I think by the end of this course, you guys could build something like that pretty easily. Or for like housing, and instead of like scrolling through the housing, if you want to get a mod, you could have a little bot go do it for you. So when your pick time opens up, it could go get and click that mod button before anyone else, and then you guys can book your mod. No guarantees on that, but that's the kind of stuff you can start to piece together pretty simply.
And Brannick is certainly not speaking from experience or anything. All right, let's jump back into it. Let me share my screen here. All right. All right. So we saw the back and forth with the post and the get, right? There's more verbs. You start to get into some that relatively rarely get used, like head or options. The big ones are get, post, put, and delete. Sometimes you'll see patch. Some of these mean very similar things. Put and patch both mean update. They technically have like subtle differences to it, but nobody respects that, and they just get used interchangeably. But at the end of the day, there are no rules to these verbs. You could theoretically make a delete request that adds new data, right? That's like, no, the internet is not going to like stop you from doing that. The server might say, no, I only I only accept post requests for this action. But the server could say, no, you could send me a delete that sends me a new blog post to add, and I'll accept it, right? So it's more about the human side of it and trying to establish standards around, okay, it makes sense that if you're going to add something new, you probably use post instead of delete, but no hard rules against it. Real quick, just to show that, if I send a delete request and we go back, same thing, right? Literally the only difference between these two, aside from the token being different, is that the verb changed up here, right? And it's the server's job to parse that, understand the request, and then do something different depending on what's going on. Cool. All right, so now let's talk about status codes. So you get a response back, either because you request a page through a GET request, or because you post data and the site needs to respond. Somehow you need to know if that request succeeded. And sometimes the server will respond, and in the data here, instead of just saying request caught, it will say, success equals true or success equals false. And you can look at that to see, did this go right? But the problem with that is then every website and system in the world would have to conform to sending data back to clients in the same way. And what you will very quickly discover as you start to poke into different types of websites is that is very much not the case. People design things in all sorts of wonky ways for no reason in really, really ridiculous scenarios. And so there's no way to enforce hey, the data that you return has to say if it was successful or not. So we need some other mechanism to look at a response and say, was this successful or not? And what that is called status codes. So just like we have HTTP verbs, which are kind of like its own thing in the protocol, right? It's like a whole category of function. Status codes are the same thing. So every response that you get from a server to be compliant with the internet and with the specification has to have a response code. Now, same thing with the HTTP verbs, where you can abuse the status codes, right? You can send the wrong ones in the wrong situation, but you have to have one. And so a well-designed server with a well-designed interface will adhere to these status codes in a reasonable way. If we look at the response that we got from this, we can see right here, see this 200 OK? That's the response code we're getting back from the server. It's 200 specifically. So the server is saying, hey, for this request you made, 200, good to go. And if we look at this list right here, there's like 40 status codes or something. But they start in the 100 range and they go up to the 500 range. And so you'll see like 200 means, okay, everything's good. 201 is supposed to mean I successfully created data, right? So if you send a post request, the spec compliant thing to do is in your response to send a 201 to say, yes, I created that thing. But you'll see tons of websites, including ones I've designed and probably ones Brannick has designed, that will just send 200s, right? So not necessarily a bad thing, not at all, right? Like it's still a status code that represents something was okay, but it's not like 100% compliant to how the internet is supposed to work. That's okay. The internet is a messy place. It's the Wild West. There are fewer standards than I think people think there are when it comes to this stuff. And so it's up to every client who makes requests to understand how that server is going to interact. That's the success.
And we'll show you guys how to do it too, but it's pretty simple.
Yeah.
Once you start building this stuff, it sounds like a lot, but it's very simple. The one you guys may recognize is 404. If you ever go to a website and you end up on some page and there's like a big sign that says 404 or you're lost, that's like, oh, okay, this page is gone. It used to be you go to an old article or something, it might return a 404 error for you.
Exactly.
Jimmy, I don't know if you want to head over to Amazon.
Oh, yeah. Good. Yeah, that's a good example.
So if you go to any Amazon URL, if you guys go to Amazon.com and you do /, you just type in a bunch of gibberish on your keyboard, it'll pop up with a picture of a random dog, and it'll say, "Sorry, we couldn't find that." That's a 404
That's their 404 page, right? Yeah, exactly.
Yep.
There's a good question here. Are these status codes automatic or set up by whoever made the app to send those specific codes for specific errors? Yeah, good question. So by default, it's totally up to the server to send the specific status code for this specific scenario. We're going to talk at some point, maybe next week or the week following, about frameworks, web frameworks, which are basically like packages you can use to get all of this on Rails much faster. Those frameworks will often have very sensible defaults in different situations. So they will handle the 404s for you, for example, right? And if you don't say, hey, when a user hits this route, do this thing, they will just assume you want a 404, right? So oftentimes it gets for you, but by default, the internet does not handle it for you. Like each server has to respond with that.
Some frameworks you guys might have heard of, things like React, like Vue.js, like Next.js, Ruby on Rails, Laravel, Flask. Those are all different frameworks people have made to make it super easy for you to handle this stuff so you can focus on just building cool websites.
Exactly. Cool. All right, Brannick, I'll hand it back over to you for HTML.
Sweet. We're going to do a super basic HTML intro here. So you guys know when we made that request to google.com, right? Google, you said, hey, server, we want to make a GET request to google.com, send some data back to us. I'm going to go ahead and open up inspect. So I'm going to hit inspect again, and I'm going to hit elements. This is the data that Google sent back to me in the most basic terms. You guys have probably seen this before. I'm going to open it up in another window. This is all HTML. It looks a little bit messy. There's some other stuff in here, but basically the thing to note is that all these websites just send you back text, and that text is called HTML. Jimmy, what does HTML stand for? I'm drawing a blank.
Hypertext Transfer Protocol. Oh, wait, I'm sorry.
HTML.
Hypertext Markup Language.
There you go. So this is all text. Even the images are just URLs to other files, right? An image is just a bunch of text just put together. It's just a bunch of bits. And the fun thing is, if you open up your Chrome and you click Elements, and then you can hover over on the page here, see this little cursor icon. We'll click that cursor icon. We can edit all of this text on any website. So we can click into it. We'll see we're clicking into some HTML. There's the text there. I'm going to say, hello, world, and then hit enter. And you can change the text on any website. So sometimes it's kind of fun. If you want to go to a news story and type in your friend's name on it, this is just changing it on your computer. It's not changing it for anyone else. But all these websites are just a bunch of text. And because they sent that text to your computer and you own your computer, you can edit that text whenever you want. So that's kind of fun. I'd recommend you guys go to some websites, play around with it, see if you can click through here. And when you're looking at the HTML, you'll notice everything is wrapped in these things called tags. Tags have two little carets that encapsulate it. So the opening tag and the closing tag. A closing tag has a / sign between those carets, and they're always paired up. So it's always the same thing. This is one of the most common ones. It's called a heading 1 tag, H1. There's our opening tag. Then in the middle, we've got hello world is the content that gets rendered. And then we got our closing tag. So I'm going to open up my code editor here. This is VS Code or Cursor. So it's got some AI in there. And I've got a blank HTML file on my computer. If we head over to my computer desktop, you guys will see here it is. I've got a folder, and then there's just a simple file in here, index.html. I'm going to go ahead and add an H1 tag. So I added the opening tag and the closing tag. Sorry, sometimes the autocomplete just does it for you. So I've got let me make that a little bigger for you guys. Got hello world. Then let's add a H2. So that's a little bit smaller. H1's your biggest. My name is Brannick. And then let's save this. So we've got a file here. You can see the AI's trying to guess what I'm going to write next. But we've got index.html, and we've got a couple tags in there. Let's go back to that file on my computer here, and I'm going to click open. What do you guys think is going to happen when I click open? This is actually going to get opened by my Chrome, by my web browser. So I'm accessing myself as a server. So my computer is being its own server. Here's the file here. You can see here it is. If we inspect that, check it out. We've got the tag 1 and the tag 2, and you can see those elements on your page here. We can edit them over in the Chrome inspect tools as well. It's just text. So when I make that request to a server somewhere else, check this out. There's actually, instead of HTTPS, which says, hey, we're going to go out to the internet, or said, hey, we're going to go to a file on our computer. It's the same exact thing. We're going to a file on our computer. We're going to this route. This is folders. So I'm going to my users folder on my computer. I'm going into Brannick. I'm going into code. Here's the name of the folder. And then here's the file, index.html. It's just text pages that are getting passed around the internet and loaded up everywhere. That is a super basic intro to HTML. We'll get more in depth into like how to style it, how to make it look pretty, how to make it look like the rest of the website. But the key thing is to understand is like all these websites, it's just text, just getting passed back and forth. Very simple. Let's see here. I think that is it. So I'll summarize a couple of the tools we used here. I recommend you guys all download VS Code. Can I get some thumbs up if you guys use that already, or is there a different IDE that they recommend at BC you guys are using? What do you guys write most of your assignments in?
Mostly VS Code.
Perfect. Yeah. Recommend getting that downloaded. I showed you guys Chrome DevTools. Most developers use Google Chrome for developing. It's the most robust browser out there. So most people install that. And then Postman, that's free. Get that downloaded. You guys can make some URL requests up to request catcher. And I'll send these slides out so you got all the links here as well. Couple of key takeaways though. Everything's just text. Going to a website, simply text. Pretty much even the most complicated websites in the world are literally just forms and just like making get requests, update requests, and delete requests. Pretty soon you'll start to think of the whole internet as just a series of these different requests, and then you got to combine it. Jimmy and I have probably written like at Area, we probably had, I don't know, we probably wrote like 2,000 or 3,000 different URLs by hand. And that's all it is. That's all these companies are. You're just stacking up all these different request types and then making it all work together. Go for it, Jimmy.
Yeah, no, 100%. I agree. And the other thing I was going to say is because everything is just text, and some of you may have experimented with this or seen this already, and AI just spits out text, right? It's really well positioned to just create the correct text that's necessary to create websites, create servers, create what's necessary, right? So we're going to get into that too, and how that helps accelerate it. But everything's just text. It's like way simpler. Yeah.
I probably write 3 or 4 times more code today on like an hourly basis than I did like 2 years ago because so much of it's automated, which is kind of fun. So it's awesome you guys are learning this stuff. And then for next week, obviously this is not a real course at all. So thank you for showing up. If I were you and you wanted to practice, here's a couple things to do. Set up these tools and whatnot, and go use that request catcher website and just formulate your own request and try playing around with paths and query parameters and just see how the data gets sent from your computer up to that server. Aman is going to set up an in-person at some point in the next couple of weeks. There's going to be some more tools we'll set up on your guys' computers to build your own servers so you can build your own websites eventually. We'll email details about that. And then the other thing I'd recommend is if you do not know how to use the command line yet, learning the command line. Could I get some thumbs up or thumbs down if you guys know the command line at all from your classes? I know it was always like these CS labs, and I never went to those, so I never learned it in school. Okay, a couple thumbs up. The main commands you guys should learn is ls, cd, make directory, and touch. And maybe we can stay late one day and go through that if you guys have no idea what I'm talking about there. But
And
this
also,
is super helpful.
Brannick, about that, if anyone wants to email me to set up like just a solo meeting, I can help you with the command line, show you the basics, but feel free to email me whenever and we can set up a time that works for both of us.
Awesome. Thank you, man. So yeah, that's it. That's the basics. Lots of terms, lots of new words. It's just all super helpful stuff as we get oriented and you guys get on the way towards building your own websites out. So we'll send out this recording too. Feel free to go back, look at it, email us any questions. And that is it for today. I don't think we have anything else, Jimmy.
Just quick look forward at what's going to happen next week. We're going to talk about how to actually put this into practice. So it's going to get really practical and really real, really fast. Today was obviously pretty theoretical, but next week we're going to like actually build stuff. So this will all prep you for that. And then we'll also have, like Branick mentioned, a guest speaker starting next week as well to make this a little more real world beyond just us. So cool.
Sweet. Hopefully it's helpful, guys. And looking forward to seeing you next week.